So this is now time to actually put this code to test and see if things will compile and actually happen when we run this application. Let me just change this to something like Rita, different cat name. Okay, so save this and try building it. It builds fine, and if I run it, so it says meow, my name is Rita, and bark, my name is Milo. So let's just adjust our screen appearance here so that we keep things readable. Some kind of background, and okay, so that looks better. So this is an example of very basic polymorphic behavior of our classes. Let me just iterate through what just happened. The biggest challenge is that we said that we would like to be managing different types of objects by using a uniform collection of them. Since this uniformity requires some level of indirection, obviously this is a collection of pointers. Now, we decided that we would like to have a base class named pet, and then we will derive anything we want from that specific pet base class, and provide derived classes. And if we want to be able to forget about the cats and dogs and their differences by using uniform function calls, what we need to do, we need to add a virtual function to print, name it whatever we name it, essentially to the base class, and say it's a virtual function. Since it doesn't make sense to write any code for print at the level of pet, we say virtual, and it's pure virtual, which means do not expect any implementation at this level. And at the same time, it's a promise that any of the derived classes will have to provide the actual version of print, and they will use just the same signature, right? It's a function that doesn't return anything, has name print, doesn't take any parameters. It's a constant function which promises not to modify any values inside the object, essentially just read-only access, right? And we repeat it here. By the way, you can also say virtual over here, but you're not required to do that, right? So usually, I think it's a good style is not to do that, and I mean, the latest that I researched on the style of coding is that you should only be using virtual at the top level when you first declare a virtual function, because from that point on, it really doesn't make any distinction. You just write normal code at the level of your objects, and magically this print will be dispatched for cat and dog, despite the fact that we're using pointers to a pet when we're dereferencing it. This is called polymorphic behavior, right? So over here, I will just get rid of this keyword, although syntax permits you to say it at the derived class level as well. Okay, so anyway, in order for this to work, like I said, you have to have virtual function, you have to have a base class. This way you can create a vector of that pointer to a base class, and then we also have to provide the derived classes and give them the functionality that we need. Now, the limitation of this demo code that I have is that I have a hard-coded cat and dog, which is most likely not the way an actual application will approach creation of objects. Most likely creation of cats and dogs will depend on the user deciding to populate collection of different types of pets, and therefore this is okay for a demo, but this is not very useful at all in terms of making it a practical application. So let me do this. Somewhere in this pet header file, actually, you know what, I will probably just now just go to say View, Solution Explorer, and just add another implementation file to my source files, and we'll say Add New Item. And this is going to be implementation file.cpp, the code that uses that has executable code, and I will simply follow the naming and say pets.cpp, okay, and it's going to go into my source directory, right? So I will just basically in this implementation file, which is brand new file, I will say include pets.h, include this header file. And what I would like to do here is that what I'd like to be able to do is to say, how about if I create a function that returns a pointer to a pet and says create pet, okay, and what it's going to do is to take a character pet type, right? Pet type, and then it will also take a string name for that specific pet. We'll just see what that does for us. All right. So let's just resize this. And add this function. Just this is, by the way, create pet is not a member function. This function is not a member of any class. It's just a normal function that has a name, create pet, and basically takes pet type, the name for the pet, and returns a pointer to a brand new pet that it's going to create. Okay, so most likely what I need here is to say the same thing using namespace std, so that I don't have to explain that string comes from the standard library namespace, uses short name like this. And what I need to do is I need to say if, or rather I can use a switch statement, right? You can say switch on the pet type, right? Switch on this pet type that the user will provide, right? And the switch statement, this is the ending of my switch statement right here. In case if this is a cat, which is C, right? So this is case C, this is going to be case D for a dog. I can create a pet dynamically by saying return new cat, and use constructor that takes the name, right? And likewise I can say, in case if it's a dog, right, return a dog with the name that the user has been asking for, right? I can also use some sort of like a default case, and for the sake of safety, I can anytime we hit this default case, I can make this program crash by saying assert. We can say unexpected pet type, okay, and we can crash the program by doing something like this. For this we also need to include cassert. So this is going to be an internal error generated by our code. Cert facility basically crashes the program intentionally. We just say, well, you know what? If we ever hit anything that doesn't look like C or D, right? Then the program will simply crash on the spot. And I can still use the break statement, and then or rather, what I can say is just return a null pointer. something like that, because I don't have anything to return. But if it's a C or D in terms of the character pet type, then I will be rather creating a cat or a dog. And we say that when we create dynamically this cat or a dog, for the compiler it's trivial to convert the pointer to cat, which new returns, to pointer to pet, because compiler knows that pet is always included inside the cat and inside the dog. So for the compiler is called upcasting, and it's trivial for the compiler to essentially create a cat but return a pet pointer, and create new dog. Of course, new returns pointer to the dog, and convert that pointer to the dog to the pointer to the pet. That's possible. So we isolate this special knowledge of the type of the pet to this specific function, which takes the type and the name and should be able to construct this, and should be able to crash in case if it's not C or D. So we need to test this.